Hi, it's Cyprien from FE4All, and today we're ready for a new tutorial. So today I decided to show you how to do a modal analysis. So we're starting to get into the dynamic analysis module of Salome-Meca. So let's open Salome and let's start the tutorial. So I created a folder on the desktop so I can save everything about the project in one folder. So I think it's a good practice. So you should also try to do the same before starting. Okay, so start the geometry module, and I'll go on something really simple. So I'll just use a simple plate and I'll do the modal analysis of this plate. So generally modal analysis is not something very complex. It's rather simple to do. But as you may know, Salome-Meca may not be as straightforward as other software, so it will require you to understand a bit more things. So that's why I intend to show you how to do that in this tutorial. So first, let's model the plate. So let's go for the simple option here, and let's generate directly a rectangle like that. So that's easier, so I just set up one side at 50 and the other at 100, apply and close, and I have my face. So that will be my plate. Now I will need to create groups in order to be able to simulate that later on. So there are two groups I need, one for the bottom edge here that I will fix as a boundary condition, and the other I will need to assign all the plate as a second group to be able to assign a thickness to this plate. So let's go in new entity, group, create group, and let's select the edge, and I need to select the main shape, which is the face here. Okay, not sure why it's not selecting. Okay, maybe I need. Okay, just click on the screen to select it. Okay, now let's select the edge, add it, and let's change the name. Let's call it bottom. Now second group. So you see that here in the tree my group bottom appeared. Now that's a second group on which I will assign the face of this, and I'll call it plate. Apply and close. Okay, so my geometry is ready. As you saw, that's very simple. So now let's go to the mesh module and let's get over with the meshing part. So let's activate again my plate. Let's zoom in, and the first thing to do is to create a mesh. So my geometry is selected. Now there are several algorithms that I can use. So if I use this one, NetGen 1D 2D, it will create triangular elements, so I don't want that. So I'll use the mapping option. But if I use the mapping option, okay, I'll have to give it some parameters like that. I need to define also a 1D algorithm that will be used to map the edges. So let's use wire discretization and choose a number of segments of 15. Okay, so that's it, right? Apply and close. Now if I just click on compute and I measure that, I will have 15 elements here and 15 elements here on this side. But as this side is smaller, I want less elements, maybe 7. So to do that, I have to create a submesh. So go on submesh, 1D. Here I have to select the geometry again, so let's select the the plate. Yeah. No, this is 1D, sorry. So I have to select the edge actually. So bottom, okay, you can select directly from the group here. And wire discretization again, and this time you can set it as 7. And the thing is that if I mesh like that, this edge will be 7, but I don't know about this edge here, so I have to use an additional hypothesis here and tell it to propagate the 1D hypothesis on the opposite edge. So I have to add this, and so we'll get the same kind of distribution on the two sides. Okay, now that I did that, I'm ready to compute. So let's go on mesh here and click on compute icon. Okay, I have to select this one, sorry. Okay, now let's see if that's okay. That's great. So I'm getting 44 edges and 105 faces. So that's what I wanted. So I can hide plate geometry now, and I'm getting my meshed plate. So now, before we go to the Aster module and really try to set up the modal analysis, which is the main purpose of the tutorial, there's two things to do. One is to create the groups for the geometry as well, because for the mesh as well, sorry, because ultimately this is what will be used to assign the boundary conditions and all of that. So to do that, I go to mesh, and there is a function create groups from geometry. So I'll use that. Now I have to select my mesh 1, and here I have to select my 2 geometry groups. So you see they appear here. So if you have nodal groups, you have to select them separately. So yeah, maybe I should actually also create nodes, so we'll be able to get values after that. But anyway, I'm just doing a modal analysis, so that's okay. If I was doing a linear static analysis, maybe I would need to define also groups for the nodes, so I'll have some points to take the values at that point. Here, that's okay, let's do like that. Now you see that I have now a plate group and a bottom group. Okay, so that's it. And there's one last thing I need to do, is to export the mesh, because you can understand it like that. There's no real communication between the mesh module and the Aster-Study module, so you have to basically to export this mesh 1. So right click, and then you have to read again this in the Aster-Study module, so it knows basically that you it knows that you have this mesh. So I'm selecting the folder I created on my desktop, and let's keep the same name than this one. Okay. Now, if you there's a common error here. If you forgot to create the mesh groups, you just export the mesh and then you read it in Aster-Study. You will find it strange why I'm not getting the group of mesh, I'm not getting the group of nodes to assign my boundary condition inside the Aster-Study module. So you will have to come back here and look that and realize that you don't have created that. So if you created those groups afterwards, after you exported the mesh and everything, what you have to do is to export again the mesh with the groups together and rewrite over the already exported mesh. If you don't do that, then your groups, even if you create them after, they will not appear in your Aster-Study module. So that's important to mention. Okay, let's go to the Aster-Study module and let's set up our modal analysis. Finally. Okay, so now I have nothing, so I have to create a stage. And the first step is always to read the mesh. So let's open the mesh I just created. Okay, I'll keep the name mesh. the second step is to create a model. So you will need to assign, so we will do it together, we'll assign a thickness to this plate using the AFCARA element function. But before we do that, we have to create the finite element model first. Otherwise, when you use the AFCARA element, it will not find this model, and then you will not be able to create this. So let's create the model first. So here I'll just select every element. This is a mechanical type of study, and the modelization, where this is where it gets a bit difficult. You have to understand what is the right modelization for this type of element. Well, what I found in the documentation and everywhere is that if you do a model analysis for a plate, the right model is this one, the DKT model. So it's a plate model which supports dynamic type of analysis. So you need to use this one, DKT model. So you can have the details about that inside the Aster documentation. So just tap on Google, Aster model DKT, and you will find the right PDF. Okay, so let's create that. Okay, that's it. Now let's create the element property. Now again, so you see here you have the model I just defined. So if you don't define this model, well, it doesn't work when you create that. Okay, now for this, what I want is to assign a thickness to this element, and the model I need to choose here is this one, coq, which means a shell in French. So that's the one you need here. Let's select a group of elements, and that's where the mesh groups I created before become handy, because if you didn't create them, you will not get those options to read the elements. Now let's assign a thickness, so 0.001. So I will work I will work in millimeter in this study, so let's just use 1. And yeah, I'm just checking that everything is right. I think it's okay. Okay, so I have my model. Now the next step is to create the material, and for that I have to define the material first. So let's define a linear isotropic kind of material. There are two things to define: the Young's modulus and the Poisson's ratio. And the thing you need to understand is that what kind of units you need to use actually. Well, because it's never mentioned that you're working in meter or in millimeters. So how does it work? Well, you basically choose what type of unit you want to work in. So if I'm entering like that 210,000, well, it means that I'm basically working in megapascal. So I'm using millimeter as a unit. If I wanted to work in meter, I have to add 30 more to work in SI unit. And you have to be careful because your different parameters for the material need to stay coherent. So if I define that in megapascal, then my density needs to be defined also in megapascal, which means that the value here will be 77 and here minus 6, because it's in millimeter, it's kilogram per millimeter cube. Okay. So if your units are not coherent, well, you will get problems also. So always keep coherent units. Now let's assign this material to my mesh. Okay, everywhere. and give it the material I just created. Okay, I get my material. Now what's the next step? Now I get my material, I got my mesh and everything. Well, I need to define some boundary condition for this plate, right? So I'm doing that using assign mechanical load. And I'll just fix the bottom edge. So for that, let's use enforce DOF. Edit, select the group of element, bottom. Okay. And okay, let's fix the 6 degrees of freedom here. So I'm just calling it load, but it's a constraint. But anyway, okay. So I got my load, and now this is where it starts to really you start to need more in order to do the modal analysis. How do you do modal analysis? Well, to do modal analysis, you have to use a new type of function, which is called analysis, which is called calc modes. So this is the what replaces static mechanical analysis. If you do static analysis, you will use static mechanical analysis. For modal analysis, you will need calc modes. But before you do the calc mode function, you need something else. You need to create rigidity and mass matrices, because dynamic analysis involves mass. That's why in my material model I added the density. Now you need to use this function assemblage, which is basically a French word for assembly. So you have to use this function here to define the mass and the rigidity matrix, which will be used to calculate your frequencies for the modal analysis. So how to do that? Well, first you have to create those matrices. So activate this first option, match as. So I suppose it means matrix assembly, and I'll need to create two matrices. First, mass-Meca, and let's call it mass. Let's call it, okay, mass. And a second one, which will be the rigidity matrix, so rigi-Meca. Let's call it rigi. And here it asks you the number of degrees of freedom. DDL means degree of liberty in French, so it's a degree of freedom actually. So here you could create a function, but I think if you just write like a variable like that, nddl, it will automatically compute it, so you don't have to worry so much about it. So that's it. And now you need to activate this material field, and also the element property. You have to give it the load condition, and that's it. So basically what this function is doing is that it uses those parameters, your material field, your element property, and your loading, to calculate the matrices that will be used for the dynamic modal analysis, and the degree of freedom. So click on OK. Okay, and then you get your assemblage function ready. Now that you get that, you can finally use the calc mode functions, which will be where this this rigi matrix here enters in play. So you have to assign it like that. So you see this is the result of the macro. The function assemblage is basically some kind of macro that calculates that for you. So, and now you need to define what kind of modal analysis you want to do, which means how do you want it to determine the natural frequencies of vibration of your plate. You have to activate the option and choose one of those functions. So to get the details about all of this, you have to look at the documentation again. So I will just use this plus petite, which means smallest, plus grande means biggest, largest, sorry, and then you have center, band means which means frequency range, and then, well, the others I'm not so sure what they do, but I think this plus petite is the first one we will use together in this example, and then this one band is also quite useful because it calculates all the natural frequencies in one specific range of frequencies. Okay, let's use this one, and I need to activate this option, calc frequency, and basically give it the maximum number of frequency I wanted to calculate. So let's calculate 10 natural frequencies. Let's okay, and I think it's all for the options here I will use. Okay, now that I did that, I need to print the results, right? Otherwise I do the modal analysis, but I won't be able to display that. So let's go into output and set the output results. And here we have to create a result file. So let's call it modal.rmed. So you see that the med format is the mesh format, but if you add a R, it becomes result format. So it's also kind of med format, but it's for the results, so they can be displayed after that. So you have to create it in this format. There are also other types of format, but I'm just using this one here. And here in result you have to activate this option so it takes in account the result from the calc mode function. And that's all you need to do here. Okay, and I think we are ready. So let's just switch to, let's save first of all. Let's save. Let's call it model. Let's go to the history view. Let's here click on the stage and let's run, and I hope it will work. You never know, there's always some surprises with this, but most of the time you find how to solve the problems in the message file. Wow, I'm getting green from the first try. That's really nice. So you can take so it means it's okay, basically I have no error. So you can look at what happened in the message file, where you will really get details about your analysis and what actually the solver did, how it proceeded your model, and you get here the list of the frequencies, the model frequencies. So you get the 10 model frequencies calculated in here. And now let's go again in here and let's view those inside the pre and post, because of course we want to also see the animation of those modes. So I'll have to right click here and open in Paravis, wait a bit that it opens. Okay, now I'm getting my plate, and let's see how to display those modes inside the pre and post, because that's not necessarily so straightforward as you may expect. So we okay, so there are several windows here. Let's try to put all together. Okay, properties, display, information. So in the properties window, okay, let's try to expand slightly, okay, like that. In this property window, you get here the different type of results that are exported from your results. So if you're not getting any kind of result, that means that here maybe there is nothing. So if there is nothing, it means you forgot to assign your results. So you have to go back to Aster-Study and activate again those results. So I think I have another video where I'm doing that. So if you have this problem, you can watch this pre and post video about Code Aster. Okay, now let's try to visualize that. So if I'm looking at the result here, I have only one result. So you may be wondering what is this result basically, because I want to see the modes, and so you have to slide down, and you see that there's two options here, time and mode. I have to activate the mode option and click on apply, and here you're starting to get the 10 modes calculated that you want to view. So this is the first mode, this is the second mode, this is the third mode, so now you're getting the mode. Now, of course, what we want to get is the deformed shape of this model, right? We want to see, so to do that, you have to generate vector, apply, and now you see that for each mode you have two types of results. You have the without vector and with vector, and if you click on vector here, you still don't see the deformation, but wait, you will see it soon. You have to add a filter in common, and then you have a function called warp by vector. So click here and scale that and activate this. Okay, and now you see the initial shape and the deformed shape. So let's try to view for the second mode, for example. Apply. No, I think I missed something. Okay, apply. And let's hide this one. Okay, and now you're seeing the deformed shape for the second mode. Now, how do you animate that? Well, there is a way to do that. You have to activate first the animation window. So to animate that, view window, and you see you have animation view. So click on that. You see you have a small bar appearing here. And before we do anything, okay, hide this one, warp by vector, and come back to the med reader type of result, and then we'll have to create a new filter in mechanics called, so you have two types, normal mode animation real, normal mode animation complex. Click on this one, real, activate it here, hide this one, and here in the animation view you have to click on the plus to add it in the timeline. And if I didn't, yeah, and then if you click in play here, you see the animation. So you can set it as a loop by clicking here, and it starts to animate very nicely. Now if you want to switch the other modes, well, you could go here and just try to switch, but there's a trick. You see that here it's actually not the right animation. So I just changed the color, but I didn't change the so you have to go, okay, you have to go, let me, property. So you see here you have two kinds. You have properties, normal mode, and display, and those two here have to be the same. This one especially, and you have to click on apply every time you do things. So these two, apply, and now okay, if I think I should be getting the animation, yeah, Right, I'm getting the animation for this. I like to activate no, not this. There is an option, so okay, axe grid, I think this one. Yeah. So now you see a bit better what is happening. Oh, ouch. Okay, so I'm getting the right color with the right animation. So you have to be careful. Sometimes you're getting some kind of movement, but the color is not matching. So you have to get, as I showed to you in this window, the two options here should be the same. If your option here is 11, so the second mode, but this one is the coloring of the first mode, then you'll get animation which is different from the mode. So that's a bit tricky. That's tricky thing I found in this. Okay, now there's one thing more I'd like to show you is how do you export those results inside a text file. So let's say you're not very interested to look in details at how those modes look like. You just want to get the 10 modal frequencies in a text file. Let's do that. Let's go back to Aster-Study and let's go back to my data settings. That's it. So now basically the output, I want to get a new file created with the 10 frequency modes. So there's two things to do for that. You have to add a function called Rusu table, which will basically take one of the variable from your calc mode function. So you have select the calc mode function, and here you have to give it the exact name of the table you want to export. So I want the frequencies, so the name is frec, and it has to be in majuscule, exactly like that. So I can give a different name for this table, frec. Okay, frec table. And this will just extract the values from the modes of the frequencies, but now I have to print them out into a file. So let's go to output and imprint table. Okay, and now we're just taking the table that I created from the other function I created, and now you have to give it a file. So let's call it normal frequency. Normal frex. Okay. Save. So you can give it a Tableau format if you want. Well, I think it's not needed to do that. So you can just like that, those two options, it's enough. Okay. And now let's run again the analysis. Run. And this time it should create another file with just the name of the frequencies. Okay, so it's failed. Let's take a look at the error message to see what I did wrong. That's why it's useful to take a look at that. Okay, the table frag doesn't exist in the results unnamed 0. Okay, so unnamed 0 is my function calc modes, which is, well, I should have give it a more fancy name than that. Okay, let's take a look why it doesn't exist. So it basically tells me that it cannot find the frac result in this. I think what I did is that in this function Rusu table, I shouldn't use name, but I should define a parameter name instead called frac. I think this is the problem here. Now, instead of defining here, you have to define it like that. I think this is the problem. Let's try again. Okay, now it works. So let's take a look at my desktop, and you see that now I have a file called normal fracs, and it just outputted the normal frequencies inside this file. That's much more convenient than having to read all the message file with all the details. Okay, well, that's all for this this tutorial about modal frequencies. I hope you really learned a lot. It took me a lot of time to do this tutorial, so I hope it was really useful for you. And if you have some ideas for the next things you want to see, please just leave a comment in this video in the comments. Let me know what you want to see, what you want to do with Code Aster, and I'll think about it for the next tutorial. So thank you very much for watching. So if you're on YouTube, you'll probably find the link to the article and the next videos inside the description. Otherwise, you can go on my blog feforall.com and click in the category open source FEA, and you'll find all the articles I wrote about open source FEA and the previous videos inside this category. So thank you for watching. I hope that you learned a lot and that you will learn a lot using all the videos that I am sharing on my blog. So if you like those videos, please help me to share them with your friends and other engineers. And also, please let me know what you think in the comments. It's always great to have some kind of feedback. And if you have some ideas of things you would like to learn or do with FEA, please also let me know. Thank you for watching again.